Welcome after the break. The next session is going to be delivered by Stott, Principal Cloud Advocate Manager from Microsoft. And I'm just hoping to find out why, if every month we are seeing bigger and bigger models appearing on the market, why we are supposed to talk about small language models at all. So Lee, over to you.
Hi, everyone. So welcome to my session on harnessing small language models with, harnessing potential of small language models. So I'm Lee Stott, I'm a principal cloud advocate in our Microsoft team. And I'm here today to talk to you about a few different things around small language models. So first of all, I'm going to give you a bit of background to AI tooling, small language models, and LLM overview. So just as Michael said, he wants to understand the difference between small language models and large language models. And then we're going to go into deployment of those language models to edge devices, because that's the most important thing today around having small language models, is taking those models and being able to deploy them as close as you can to the actual resources that you want. So if you think about robotics, you think about infotainment systems within car entertainment, they are all now using small language models. And again, they may have internet connectivity or they may be completely standalone. So we want to talk about what the different opportunities there are, and then hopefully we'll open up this to a set of questions and answers. So I'd love to have some questions from you as the audience around how you're using this technology, what your thinking is around this technology. So let's get started. So first of all, from a Microsoft perspective, we're trying to build a single AI tooling service for you as developers to utilize. And really, we want this to be the best in class AI foundation service. So we have things like Azure AI services, which were previously the cognitive services. So if you use things like vision, speech, text, they're all now bundled as our AI services. We have our Azure machine learning services. So this is really around hardcore machine learning and data science activities where you want high volume compute or clustered compute to undertake machine learning experimentations. We then have responsible AI tooling, and this covers all the different areas, because again, if we're doing stuff with AI, we want to be doing this responsibly. That's the key aspect that Microsoft is trying to drive home in all our engagements, is just because we can do it, should we be doing it? And if we are doing it, what's the evaluation, optimization, and more importantly, the compliance of that AI system in production? We then come to the developer stack, and in our developer stack, we have the Azure AI Foundry, which is our platform as a service solution. So this is a cloud hosted solution. It was previously called AI Studio. It's now being encompassed into AI Foundry to take in the responsible AI, the machine learning, and the AI services. And then we have a new option called AI Toolkit for Visual Studio Code. So if you're a Visual Studio Code user, you can now utilize AI directly within Visual Studio Code using the AI Toolkit extension. It utilizes GitHub models, which you saw previously from Curry, so that you can get started to do that proof of concept, MVP, evaluation and deployment as a non-production service. It's that experimentation perspective. And then when you want to productionize it, you move over into AI Foundry to produce this and deploy this as a solution. So when you actually come to consider a language model, whether this is a small language model or a large language model, these are some of the key criteria that you should be thinking about in terms of that deployment and that use of the large language model. So number one, what is the AI quality? What do you want to actually perform with this solution? The customizability, and I'll talk a little bit more about this, and there's been a few sessions today about RAG or fine tuning. You know, do you take a base model? Do you RAG it? Do you fine tune it? Then what are the features of that model? And this is where things like the benchmarking solutions really become key to choosing the right model for the right task. So a great example is if you want to have a chat-based interface model, go for a model that is classed as an instruct-based model because it's been pre-trained on, natural language interpolation and textual input. And then it's really around the price, the cost, and the latency. And this is really where small language models become very interesting, because you can actually start to use these at the edge, which become free in terms of that utilization. There's no hosting costs. Again, you're limited in terms of token, etc. But it becomes really key to how you want to implement and design these solutions. So when it comes to really evaluating these models, you should be looking at the tasks that you want to do. You should be looking at the performance metrics that are being provided by all the model providers and the cloud hosted providers. In Azure AI Foundry, we have the model benchmark, which allows you to compare and contrast different models against different scenarios and tasks. Data requirements are so key, and this really brings us on to that RAG and fine-tuning option. And then, of course, computational efficiency. You know, how do you want to host this? Is it going to be GPU on your own machines, or is it going to be GPU in the cloud? And again, ethical considerations really tie into that whole aspect of responsible AI. So when we can come to actually consider small language models versus large language models, there's a few key characteristics. So as Microsoft, we class anything under 10 billion parameters as a small language model. So if you take, for example, the Phi series, you run it around 8 billion parameters for a larger Phi model, so like the Phi-3 Vision. Whereas you compare that to GPT-4o, you're talking about 170 billion parameters. So the models are much larger from a large language model perspective. And again, this has like real key characteristics if you want to do fine-tuning. Fine-tuning on a large language model, you know, you need at least 1,000 data samples, and it's going to be very, very costly and very time-consuming to actually fine-tune a large language model. With a small language model, you can have about 100 data samples, tune the model based on those, and it's going to be a very quick process, and it's going to be a very cost-effective process because the model is so large to start off with. So really, it's really around the scenarios of where you want to run this. If you want to run inferencing at the edge, small language model. If you want to run low compute, small language model. Again, if you want to run more intensive data, a large language model. And again, we're in this situation now of where we call hybrid options, or what we call execution providers. So you can have inference into a small language model, and then if the response is not good enough, or the user doesn't feel it's good enough, you can then inference to a large language model to get a more comprehensive answer. So again, we're in this great opportunity of mixing these two together. Now, if we actually compare these different models, this is an example of where the Phi model series sits in comparison from a benchmarking perspective against the large language models. So along the bottom axis, you have the size of the models in billions of parameters, and in the vertical axis, you have the actual quality of the model. And as you can see, Phi 3.5 method of experts, so the MOE model, is very, very performant. It's very small, so it's less than 8 billion parameters, and it's up to 80% in terms of accuracy. So it's beating things like Gemma, it's beating the Mistral model. So again, size is not just about the size of the actual model, it's the quality of that model. So, you know, when we look at small language models, if we take the Phi series, we range all the way from Phi 3 Mini up to the Phi 3.5 Vision and MOE models, which are the largest size models. Now, when we look at the opportunity of these models, it's really around availability. These models are available from Amazon, from Hugging Face, they're available from Azure model catalog, and they're available from the GitHub model catalog. So you can access those models from those three different sources. Again, in terms of the platform deployability, this is where small language models really strive, is that you can deploy them anywhere, whether it's a mobile device, whether it's an edge device like an NVIDIA chipset or a Raspberry Pi, or even to a mobile phone. And now, more importantly, with the Windows Copilot, so the AI PCs that have just been released, we now have Phi Silica built into those PCs, so that you can now start to extend using the Windows Copilot runtime and build applications that need just sit within on the device. They don't need internet connectivity, and they run an API and SDK that then can build Copilot enabled apps directly in the Windows platform. So again, if you want to build a customized application for your use case, that can be isolated to the machine and run just on that machine. And there's various different options of deploying that, and I'll talk a little bit more around those in a bit. So really, when we look at the on-device aspect, there's some real key challenges. Number one is latency. We all know about internet latency, especially if you're deploying things in like an agro-tech scenario in Africa, for example. You know, internet connectivity is not great. You've got white space in terms of low broadband connectivity, but latency is going to be a key issue for you to use execution provider or cloud hosted models. Accuracy of the model is really key. You know, you want your model to be as accurate as possible, both in terms of the response and in terms of the token count that is actually utilized. And again, this is really driven by hardware constraints. You know, this might not be a GPU, it might be a CPU, it might be an NPU. So you want models that fit specific hardware requirements. And this is really where the user experience is key. If the latency is bad and the accuracy is bad, the user experience is terrible. It could have the best PC or the best connectivity, but without these three factors, this is where issues are caused in terms of that user experience. So what I want to do is swap over to a demo. So this demo is utilizing the phi model. And what we want to do in this demo is demonstrate how to, like, number one, utilize a model at the edge and some of the scenarios that could be undertaken. So let me switch over to the demo. So in this example, I'm actually building a recycling solution. And this recycling solution is aimed at an edge-based device. So the concept is a user can either upload an image or use a video to actually interact with this application to then understand, is an item recyclable? And this is using a phi model, and it's using a local model, and it's using Gradio to build the web infrastructure. So this is a Gradio app. And I'm going to basically select some options. I could use a camera if I wasn't presenting, but I'm just going to upload some images to this. So I'm going to give it some images of some rubbish. So as you can see, this has immediately come back. So do you see the inference time? It said trash. So let's upload a different model. So this is some images and magazines. Again, it's saying, yes, it's recyclable. So the inferencing time is super, super fast. Again, a breakfast. And it's saying, no, this is not recyclable. It's actually a plate of food. So it's like really fast response times. And this is what you want from a localized model. It's that super fast inference, super fast engagement from an end user. Again, we're drawing them in from like a UI aspect to give them a visual aspect to visit recyclable. We're giving them a very short textual description that's coming from the language model as well to actually say what the resource is. So if we look at the code, this is the example of the solution. Again, the QR code had a link to this set. This has been done in Python. It's about 47 lines of code. So basically we're using the Phi3 model. We're wrapping it with PyTorch, and then we're interfacing using very simple Azure inference APIs and SDKs for a cloud hosted model. And for the local model, we're actually calling the model from our local storage. So you can see I've got the Phi Vision Instruct model locally stored on my machine to actually undertake this task. So again, we've had the options within this sample of either using cloud inference or local inference. Again, if you're running local inference, you do need to utilize a GPU because it's using CUDA, but it's a very simple process of undertaking this example of producing a localized model that sits at the edge that a user can utilize to perform a very, very, well, it's not a simple task, but a very interactive task with the end user using web camera, image import from a file storage, and again, having that response back from the model, which allows us to define it. So if we go back to the slides, really, when we look at building cloud solutions, we're really looking at, number one, using the most cutting edge models. And this is where the model catalogs in the different studio solutions, in our case, Microsoft AI Foundry, are really key. We're up to 1,800 models today within the model catalog. And again, there is models being uploaded on a continual basis, from fine-tuned models to business critical models to industrial based models. Again, it's really about how do we build on that tool chain. So what are the tools involved in this? So again, you might be looking at building a solution, but an LLM might not be that solution. It might be an AI service or a cognitive service and a fine-tuned cognitive service. So it's about understanding what tools are available for you to then utilize it. Again, Curry showed in his example of the Azure Inference API, where you can literally have the same code base and just simply swap the model names to then evaluate which is the best model to choose. And most importantly, it's about that responsible AI aspect. Once we do it, how do we evaluate it? What results are given? Is it, the groundedness, the relevance, the coherence? Is it the content safety? And again, how is our model being protected from things like prompt injections, jailbreaks? So the AI Foundry is really key at providing this enterprise grade security solution around permission, security, projects and hubs, first class models available from both Microsoft and other partners in that model catalog, and then business like specific models that have been produced and made available under the model catalog as well. And then this allows us to take those models to the edge, embed safety within those models, and again, utilize things like Onyx, where we can actually start to deploy those models directly to edge devices specific to that platform. So when we look at customizing models, we really have two solutions. We have RAG, so retrieval augmented generation, or fine tuning. Now, when we're doing this with small language models, RAG is not a great solution because you utilize an Azure search, you need internet connectivity, you might have a vector database. So if you want to have this at an edge, doing RAG on a small language model means you have to have a connected model in most cases. So if you are building custom models from a small language model perspective, so if you have a production plan picking up Bic pens or Parker pens, and you need to recycle this to now be a cardboard box, a fine-tuned model deployed to those edge devices is much more effective. So what are some of the techniques for edge deployment? Number one, it's about building and utilizing the smallest model possible. The smallest footprint allows you to go across the most devices. Again, as I said, fine-tuning a model. To fine-tune a model, you heard about it earlier today, you either have to optimize a model, quantize the model to make it as small as possible. And that will optimize the model graph. You're creating those new evaluations. And then you really want to exploit the hardware. It might be an embedded device, it might be an NPU device or a GPU device. And again, it's about then serving the content, utilizing the most appropriate fine-tuning mechanism. So the two most popular are LoRa and QLoRa. And then you want to compress the model again to make it as small as possible to get it below that 3 billion parameters. So that's like the key goal of what we want to do. And what we've been doing from a Microsoft perspective is really looking at what the solution landscape is and then what solutions we can build and make open source or available to you as end users. So if you look at fine tuning, there's lots of different technologies out there. Again, with runtimes, model formats, optimizations and hardware. And what we want to do is really build a solution that offers you the best opportunity in building that single source code base and then delivering it to the customer. And this is really where Microsoft Onyx runtime comes in, because Onyx allows you to build and compile a model with the various DLLs for the different platforms. So you're building a model with all those DLLs available. And then Microsoft Olive is our optimization and fine-tuning technique to build those models and get the most quantization and performance out of those models. So when we look at this optimization runtime, so this is based on the Onyx runtime model. We have our Azure SDK, so we can call Azure models as a service and deploy those models directly hosted from Azure, just inference them, change the model names, and use the same code base. Or we might want to take an Onyx model and then compile that model to have the right runtimes for the various device platforms that we want to cater for. So it's the same code base, we're just taking Onyx to make it available across those different device patterns. And then it can utilize CPU, GPU, NPU. And again, this is all open source under the Onyx Foundation. And then we partner with people like QNN for Qualcomm, OpenVINO with Intel, Vitis for AMD, DirectML is another option for doing this. And then we also have the WebNN standards with Intel. So we're trying to look at the different ways of deploying this to have the most performance out of devices. And then we have Microsoft Olive, which is our fine-tuning and optimization. So this is a CLI-based tool. It's open sourced as well. It's on GitHub. And again, the whole idea around Onyx is doing that conversion. So convert the model to an Onyx model, do that transformation, then do the compression, then do the quantization, and then have the output available to run on any device. And this is a really slick process. It's like 20 lines of Python code, super efficient, really easy to utilize. Again, you do need GPU compute to do the inferencing and the fine tuning, but once you have that fine-tuned model, you can deploy it in an NVIDIA Jetson, on an Android device, on an iOS device, on a Windows device. It doesn't really matter. You can deploy that on any device. So when we want to bring all this to our devices, we have the Onyx runtime, which is that high-performance cross-platform solution. It allows us to build the model, deploy the model at the edge, then have the right DLLs to allow the devices to interface that model. We then have the Onyx runtime and Olive, so about building those really cool fine-tuned models that are quantized and optimized for the best output to then run on the edge. And then we have this hybrid approach using the Onyx runtime and the Azure execution provider, or Azure EP. And this is the ability to call hybrid models, so have an on-device inference, then offshoot to the cloud as well for that hybrid inference aspect. And this is really how we start to build out these enterprise scale applications and services. So the next demo I want to talk about is like the opportunity of small language models on device. And what we're going to do in this demo is we're going to take an Onyx model. So this is an Onyx model available on Hugging Face. And we're actually going to download this model into a browser. So we're going to be using the Edge browser. You can use Edge, Chrome, etc. You do need to turn on the web GPU flags because this is still like slightly experimental. But I just want to show you this to show you the potential of where we're going to go with small language models. And again, around confidential and secure compute, we're actually going to take this model and download it and run it directly in the browser cache. So it's not on the machine, it's in the browser cache. So as soon as the browser is closed, you lose connectivity. You know, that data has gone. But this is really cool in showing you how you can do this. So let me switch over. So this is the demo. And what I'm going to do is I'm just going to load this website, and you can see it's loading the Phi3 model, which is an Onyx model. It's loading the transformer from Hugging Face as well. So this is directly off Hugging Face, and it's 2.1 gig, so 2.2 gig. To show you how this runs, I've just opened the developer tools in Edge, and you can see like at the moment I've got nothing because it's still downloading, but now it's appeared in my cache. So if I look at the cache storage, I'll actually see that these models are being cached in the web browser. So you can see I've got the transformer.js and it's 1.9 gig. And then I've got the actual Onyx model. So the Onyx model is cached, the transform is cached. So now I can actually talk to this SLM. So it's just a chat demo and ask it a question. And again, this is using the Phi model. This could be, you know, any model, any small language model, which is being converted to Onyx. But I just want to show you, this is less than 2 gig. Well, it's 2.2 gig of cache memory. And this is a response. Human response time is between 15 and 20 tokens a second. This is running around 10. So, it's readable and it's amazingly fast in terms of, the inferencing time it's taking. And again, this is just running purely in the web cache. So as soon as I close the browser window, this demo goes away. The content goes away, the knowledge goes away, the model goes away. So again, this could be like a really interesting scenario of how you start to think about secure computing, confidential computing, and again, having those models running on really low performant devices because it can just literally run in the web cache. This is just using web GPU with the Onyx model. I'm like completely blown away by what this can do. And again, you can see that the context is pretty good. If you have this as a fine-tuned model, you can have then a much more succinct response. But this is quite a verbose response, but it's pretty good. It's very accurate. So if we look at bringing all this together, we have Olive as the tool chain to take our small language model, so our base model. And again, this works with any model. So it's not just a Phi series. It could be Llama, it could be Mixtral, it could be any model that's out there. We use that tool chain to optimize that model, to quantize it, get it as small as possible. That's the whole goal of using Olive. Let's get it performing. We then have the set of the Onyx DLL runtimes, which make it available to all the different cross-platforms. So we're going from Olive, using the Onyx runtime, to actually deploy that model at the edge. And this is what's really key, is we want to get this model running on any device. So if we look at this from a Microsoft perspective, we really have these different areas. So we start off with our Azure AI Foundry. This is where we're going to get our models from. This is where our models live. And they either live within the AI Foundry as a public model, or they live within ML Studio within AI Foundry as a private model. So if you've done your optimization and quantization using Onyx, you can then upload that model to the model catalog as your inferencing model for your estate, for your department, for your IT group, your project. And that can be a secured model under Azure governance. So, you can have resource groups around that, security groups around that, so that only the people with the right permissions can get access to that base model. That's your source of truth. You then build your application, and you can then build it and optimize it based on the different platforms that you want to do. So if you want to host this in a cloud model, you can create an Azure container, host it in the Azure Container Service. You can host it in a VM on a VM box or an IS box or a PaaS box. And that then becomes your inferencing engine. Or you might want to take this to be in a mobile app. So you can deploy this to an app store, whether it's Android, whether it's iOS, and have this as a consumable app that's available across those devices, or even Windows Store as well. So this really allows you to take a single deployment, optimize the model, build your application around it, build those specifics around the different application types, deploy that model, and then interface with that model using the Onyx runtime. So the Onyx runtime, ORT, is the Onyx runtime API, which allows your application to interface with that model. So again, we've taken a small language model, deployed it, optimized it, and then made it available to our different solutions. So, we've done a bit of a whirlwind tour there around all the different scenarios of taking a small language model. Again, from a small language model perspective, it's about the size. That's the key thing is what is your use case? If it needs to be small, if it needs to have very low latency or unconnected services, and you can fine tune that model as well. Small language models are the de facto go-to. Never consider a large language model if you want to do a fine tune, because it costs you hundreds of thousands of pounds to do it effectively. Again, the opportunity as well around continual inferencing and continual fine tuning. So you might be running a robotics production line where you need to change that production line on a regular basis. So if you need to ship models to each of those robots, what is that cost to you as an organization? Small language model, super small. Large language model, huge. Are you using cloud-based inference? So we've got lots of resources for you. We have the Phi 3 cookbook, which is like our cookbook for anything to do with the Phi models. So that covers Phi 3 all the way up to 3.5. We have a link to the Onyx runtime and Gen AI services and a link to the Microsoft Olive resources. And also we've got a section around our AI Tour repo. So Microsoft's running the AI Tour at the moment, which is a global event, and we've built lots of demos and lots of samples around how to implement AI into your business services, from large language models to small language models. The final one is really around, we have a DevAI Summit, Cloud Skills Challenge taking place across this event. So if you want to learn around this technology, you want to get upskilled on this technology, this is a great way of doing it. And again, if anybody says they're an expert in this field, they're a liar. This is changing on a daily basis. So we're continually learning, we're continually building new samples and new solutions, we're continually adapting and building our new models. And this is going to go on for the next few, it's going to go on now. So this is a continual learning exercise. So I hope everybody's really enjoyed this session. Again, I've left some time for questions. So if anybody does have any questions, I'd love to take some questions. And again, I'd love to have your feedback around this whirlwind session. It's been fast paced, but I hope it's given you some thoughts and some information that you can take back to your organizations.
Thank you, Lee. There is actually one question that appeared in the chat window. And the question is, will it work out of the box? Was thinking about Onyx in a web a year ago. I assume the question refers to the demo you presented in the web browser.
Yeah. So the demo will work out of the box. Yes. If you go to the demo, it just literally works. So there's two options in the demo. There's a Hugging Face, download the model, run it locally as a local inference model. You will need a GPU on your machine to do it. That's the caveat. It will need a GPU. But if you want to run the same application with cloud inference, you just need a GitHub account. We've made it as a GitHub model, which is completely free, and it will work immediately.
Thanks so much. I actually have one more personal question related. How do you foresee the future of development of this, small versus large scale models? Because one approach is obviously to take large model and accommodate it to the smaller size, the quantization, distillation, etc. But maybe there is a niche for the producers dedicated solely to the smaller size models. How do you see it?
Yeah, it's a great question. So I think over the last couple of weeks, so in the last 2 to 3 weeks, there's been a huge influx of pre-trained, fine-tuned small language models. So great examples are like the Bayer model, and there's other models that have been released over the last few weeks, which are basically taking the small language model, because again, it's about how much do you need to strip from these models in terms of optimization and quantization. You want to reduce the models as much as possible. So, what we're actually seeing now is a huge trend in industry-specific models now being produced, which are very industry-specific. So they do this function or this task, and they are super small. They're like 1 to 2 gig in size. And I think what we're going to see is more and more factors around that quantization piece to get these models as small as possible. I think this is where we're trying to really go with the Windows Copilot runtime. So again, if you're interested in looking at like how this can be applied to the PC platform, have a look at aka.ms/WCR. And this is the Windows Copilot runtime demos. And there's some amazing demos on there of like AI-driven applications. So like there's a great example of a university application for taking notes, and it's like a OneNote solution, but you take your notes and then you can highlight the text, do summarize, and it summarizes. You can do voice notes. And again, that's all based off a small language model. So when you look at that plus a fine-tuned model, I think that the industry is going to go that way, because again, it's about, the cost, the deployment times are so key. The lack of connectivity is so key to anything that is IoT based. So I think, there's going to be a huge influx of IoT or smart AI driven low cost platforms which will use small language models, whether it's a mobile phone, whether it's going to be one of these intelligent rings. But you're not going to get that with a large language model. No chance. The capacity of those devices is just not good enough. And I think that's where we're going to see a huge trend and huge change in the way people are utilizing these models.
Thanks for that. And I also noticed there's one more question in the chat window. So small models are like microservices. Interested, can they be used as AI agents?
So that's a really interesting point, actually. So, my advice to anybody who's building an AI agent is, number one, an AI agent is a multi-agent scenario. So I always use the example of a travel agent. If you're building a travel agent solution, you've got an agent which is responsible for like your flight bookings, an agent which is responsible for the hotels, an agent which is responsible for excursions, an agent which is responsible for restaurants. So each agent should ideally have its own model, and that model should be an expert in what that agent is trying to do. And again, small language models are going to be so important in those scenarios. If you think about it, you can have a small language model which is your hotel catalog, reservation service. It knows everything about TUI, for example, and it knows all the hotels that are in that range. You then have a small language model about restaurants, and it just knows the restaurants in Italy, for example. So this is where small language models become so key in that agentic framework design. So 100%.
Thanks for that. And I believe this is all that we have as far as the questions go. So thanks so much, Lee, for the great presentation, and we see each other after a short break.
Thank you.